स्वागत 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 आप सबका स्वागत है अपने YouTube चैनल द आर्ट ऑफ प्रोग्रामिंग पे। हेलो एवरीवन, वेलकम टू योर ओन YouTube क्लास द आर्ट ऑफ प्रोग्रामिंग। In this video we will talk about how do we convert a number of one base system to another base system. Normally we have already studied in constants that decimals can be integers can be decimals, octals or hexadecimals. Video link of constants is given here. If please watch that video before watching this particular video. Now let us see what are the different types of conversions we have. The first number base system that we have is binary number system. Now what is binary number system? Binary means 2. It is for base 2. It is in base 2 system. Now base 2 means only two numbers can be used, that is 0 and 1. And the data in the computer is stored in the form of binary. All the numbers, alphabets, everything is stored in the form of binary, that is base 2 system. The second system that we have is the decimal system. Now this decimal is base 10 system. This decimal is base 10 system. That means we can use from 0 to 9. Normally we use decimal system in our day-to-day life, that is for base 10 system from 0 to 9. All the numbers are made up from 0 to 9. The third system that we have is the octal system, and this octal system is base 8 system. Base 8 system, that means digits from 0 to 7 can be used. And the last one that we have is hexadecimal system, and the last one that we have is hexadecimal system, and this hexadecimal system is base 16. Base 16, that means we can use digits from 0 to 9 and A to F. A is 10, B 11 and so on up to F is 15. Now a given number can be converted from decimal to binary or binary to decimal. A given number can be converted from binary to octal or octal to binary. Any one of the conversions is possible. That means you can convert any number from hexadecimal to binary, hexadecimal to decimal, hexadecimal to octal and so on. All these conversions are possible. But the important conversion over here is from decimal to binary and binary to decimal. But anyway, we are going to see all these type conversions in this video. That means we will see how do we convert from decimal to binary, decimal to octal, decimal to hexadecimal, then binary to decimal, binary to octal, binary to hexadecimal and so on, so that we clearly understand how a given number can be converted from one system to the another system. Now let us see how do we convert a decimal number to a binary number and binary number back to a decimal number. Let us now see how do we convert a given decimal number to binary number. Now in this video we will talk only about the positive numbers, how positive decimal numbers are converted to binary numbers. Here we are not going to talk about the negative numbers. Negative numbers we will talk after we learn the 2's complement of the number, that is integer representation of a number in C, after we study the data types. But as of now, let us see how do we convert a positive number in decimal form to a binary form. Say for example, we want to convert 13, the number 13. This is in base 10 system and we want to convert this number in binary. This is the base 2 system. Let's see how do we convert it. Now we know that in binary representation we can only use numbers 0 and 1. We cannot use any other number. Now how do we get the numbers only 0 and 1? Whenever we go on dividing the number by 2, you get the remainders only 0 and 1. That means we take this number 13 and we go on dividing it by 2. We go on dividing it by 2. Now we say 2 6 jar 12. What is the remainder? 1 is the remainder. Now this 1 is the remainder. 2 3 jar 6. 0 is the remainder. 2 1 ja 2, 1 is the remainder. Now whenever you get 1 as the quotient at the end, we stop, and what we do, we write these remainders from bottom to top. We write these remainders from bottom to top. Therefore 13 in decimal is equal to 1 1 0 1 in binary. 1 1 0 1 in binary. Now let's see one more example. Say for example, we want to convert 24 of base 10 in a binary number. How do we do it? We take 24, go on dividing the number by 2. 2 12 ja 24, what is the remainder? 0. 2 6 ja 12, what is the remainder? 0. 2 3 ja 6, what is the remainder? It is again 0. 2 1 ja 2, what is the remainder? It is 1. Now whenever you get quotient as 1, you stop and you write the numbers from bottom to top. You write the remainders from bottom to top. Therefore 24 in decimal is equal to 11 000 in binary. 11 000 in binary. Now this is how you convert a given decimal number to binary number. I want you to try converting 25 of decimal to binary and convert 37 of decimal to binary and get the answer yourself. Now this is how you convert decimal number to binary. Now let us see how do we convert a binary number back to decimal. Let us see how do we convert a binary number to a decimal number. Now before this, say for example, we have a decimal number as 1 2 3 4. How do we write in tens power? We write this as 1 into 10 to the power 3 plus 2 into 10 to the power 2 plus 3 into 10 to the power 1 plus 4 into 10 to the power 0. This is the way we write it. Now why we write 10 to the power 0? Because this is units place, that is 10 power 0. This is tens place, this is hundreds place, and this is thousands place. And why do we write 10 to the power? Because it is in decimal system. Why do we write this is in 10 power? Because of the decimal system, we write it as 10 to the power. Now the same thing we will apply while converting a binary number to a decimal number. Say for example, the given binary number is 1101. The given binary number is 1101. Now this is units place, tens place, hundreds place, thousands place. Is that okay? Now let's write this in the form of boxes. This is units place, tens place, hundreds place, thousands place. Now how do we write this? This is equal to, now what we have taken here, we have taken 1 into 10 to the power, the placeholder. Why 10 to the power? Because it is decimal. Now here the number is binary. Therefore what do I write? 1 into 2 to the power 3. Why 2 to the power? Because it is in binary. Binary is base 2. 2 to the power 3. The placeholder, the place at which this one is available, plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. Now let's evaluate this. This is 8 plus 4 plus 0 plus 1. This is equal 13 in decimal. Now just now we have did it. 13 in decimal is 1101 in binary. Let's take another example. Suppose we have the number 11001. Let's convert this number to decimal. Now what is the first thing that we write? We write the placeholders. We write the placeholders. Units place, tens, 100, 1000, 10,000 and so on. Now what we do? We write 1 into, why 2 to the power? Because this number is in binary, 2 to the power 4 plus 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. And it becomes 16 plus 8 plus 0 plus 0 plus 1. This is equal 25. Therefore, this number is 25 in decimal. Similarly, I want you to calculate what is 11,100,000. This number is in binary. Now I want you to convert this in decimal and take another number 1010110. This number is in binary. Convert this number to decimal. I hope that you have understood how do you convert. I have only talked about the positive numbers. I haven't talked about the negative numbers that we will see after we study the data types. I hope that you have understood how do you convert a positive number, a positive decimal number to binary, and positive decimal binary number back to decimal. So friends, if you are new to this channel, please subscribe this channel, share this channel with your friends. Please leave a comment on how do you find this video. Thank you friends for watching this video. Have a great day.